So I'm going to talk about PDF 2.0 updates for color processing and for page and color rendering. I'm also going to, wow, this mouse is not working. That's all right. So a bit about me. I am the Chief Product Officer at Datalogix. I am also the Chairman of the PDF Association. I've been involved with the ISO committee TC 171 that had been working to put together PDF 2.0. I haven't necessarily been involved for all 10 years that it took us to get PDF 2.0 out in the world, but I've been involved for a fairly long time, including what we're doing post PDF 2.0 as we go to extend PDF on into the next years. PDF 2.0, as far as color processing and rendering goes, brings about a number of important additions, important changes, and I'm not going to show you yet which deprecations are important because they're deprecated. Get the joke? Haha. Just kidding. But what I want to emphasize is that while I'll be talking about some changes to the specification, by and large, PDF 2.0's rendering and its color processing takes most all of its cues from PDF 1.7 and from earlier PDF versions. That is to say that even though I'll talk about PDF 2.0 as if there are significant differences, and don't get me wrong, these are significant differences, but for most use cases, for most instances with existing viewers out there, users aren't going to notice a whole lot of difference opening PDF 2.0 files unless you take advantage of new features in PDF 2.0. So this is both relevant and yet, for most users and for most cases, they're not going to notice any differences at all. So both important and unimportant. Well, that's kind of the dichotomy of PDF, right? It gives a great deal of functionality so that we can have very precise, very customized, and very featureful workflows that 99% of users don't really take advantage of anyway. They just want things that look the same between their computers and their devices and whatnot. So with that said, I'll first talk about important additions to PDF 2.0's color processing and rendering. Probably the most important color addition or change to PDF 2.0 is the inclusion of black point compensation. So black point compensation deals with a very common problem in color conversion, and that is, how do you map from a source color space that has a rich definition of what black is, what an absence of colorant is in most cases, to a destination color space where your blackest black is less vivid. Sometimes you deal with the opposite case too, mapping into a destination color space where your blackest black is more vivid, but your problems really come up in the case where you go from a source color space with a more vivid black definition than your destination color space. So typically in most color workflows that do not compensate for these different definitions of black, what's known as black points, what you'll find is a mapping that clips off blacks past a certain level of darkness and that's how they fit into a destination color space where your blacks aren't as vivid, aren't as black. What black point compensation does is allows algorithmically for a better mapping from these source color spaces that have more vivid black definitions to a more gradual or a more suitable destination set of black values, so that you don't end up with this sort of dive off a cliff where you lose details in your shadows and in your black regions. Many PDF renderers already have the ability to apply black point compensation when rendering PDFs, but this hasn't been a part of the PDF specification until PDF 2.0. PDF 2.0 actually extends how black point compensation may be requested. It takes it not just on the document level, not just on the page level, but brings it into the actual graphic state that you're using when you are performing PDF graphic operations. So what this means is that different contents on a page can have different specifications for whether to apply black point compensation or not. So there are 3 allowable values in PDF 2.0 in an extended graphic state dictionary for black point compensation. These are, of course, on, off, and default, or what I'll call whatever. Now, on is fairly self-explanatory. When this is specified, you're rendering, it shall perform black point compensation. And don't worry, we got a standard for that. That's ISO 18619, which I'm sure all of us can quote front and back, right? Yeah, don't worry, me neither. But the black point compensation's in there somewhere, I'm sure. There's off, which if you specify this will force earlier behavior, PDF 1.7 and earlier behavior. And then default is the default if there's no black point compensation specified. You know, hey, default to default. How about that? And essentially what this preserves the status quo of PDF renderers out there, which is to say when default specified, the PDF renderer, the PDF processor may perform black point compensation if it so desires, but it's under no obligation to do so. So black point compensation is relevant and is specifiable for all render intents except for absolute colorimetric rendering intent, which makes sense, right? In an absolute colorimetric rendering intent, you want source and destination values to be mapped as exactly as possible. You actually are choosing to have that clipping happen if there is a source black that is richer than your destination. Other important addition to rendering for PDF 2.0 is that annotations may now specify transparency, or to be more technically precise, annotations may now specify an opacity value. So they may be more than just fully opaque. This can be specified in an annotations appearance stream. This is now legal. And in annotation appearance dictionaries, there is now an opacity specification such that when annotation appearances are regenerated, for example, when a user changes an annotation in a viewer, the appearance of the annotation when it's regenerated now has this opacity that can be carried through and specified and maintained by viewers and processors. In addition, the rules for determining what pages use transparency now account for annotation content streams. Important note that these rules don't, I believe they don't account for annotation appearance dictionaries, simply content streams of annotations, which, if you think about it, makes sense. You need an appearance stream for an annotation in order to have anything to render on a page. Couple of important additions. There are more important changes and modifications to the specification than there are new features. A few of the most important ones, probably the most important one, is better guidance for transparency rendering. So, over the decade while PDF 2.0 was being created, it turned out that we discovered there are significant points of ambiguity with PDF 1.7 as far as transparency handling is concerned. And PDF 2.0 really did a lot to kind of reduce this ambiguity and to bring greater reliability and standardization to transparency handling and rendering. So there's now better guidance on when objects that are involved in transparency rendering, when they need to be converted to a blending color space and when they don't. There's better guidance on determining what the actual blending color space for transparency in a transparency group shall be. That's a new annex in the PDF specification, Annex P. There is clarification on how the special separation color name is handled inside transparency groups. The all separation color being a way of saying that a device shall use every colorant that it has available to it. So in a CMYK alternate, for example, she'll put down color in the CMYNK channels. For presses that have spot colors, it is to put down each and every individual ink all at once. So there was a lot of ambiguity on how to handle the all separation colorant when it came to transparency and transparency groups and what the meaning of this was when it needed to be converted into a blending color space. That's been clarified. And finally, there are stated rules now for determining if a page has elements that are involved in a transparency operation. In other words, rules for determining, do I need to use a transparency-aware rendering pipeline for a given page? Annex Q lays down an easy-to-understand algorithm for determining that either, yes, I need to use a transparency-aware rendering pipeline, or no, there's no effective transparency on this page, and I can render without a transparency-enabled pipeline if I, as a processor, so choose. A couple of fairly minor seeming corrections to a couple of the blend modes for transparency for the color burn and the color dodge blending mode formulas. There were edge cases where these functions as defined in PDF 1.7 had what many considered to be undesirable values at edge cases, at the two edge cases up on the screen here. what we found when looking at PDF 1.7 implementations is that while there were correct values by PDF 1.7 for color burn and for color dodge in these cases, it turned out that processors were not going by the standard, but were actually doing the correct thing instead. So we decided, instead of going after all those processors, why don't we correct the PDF standard instead? So for PDF 2.0, we've made those corrections and have aligned with existing implementations out in the field that were doing what users expected. General rendering changes. There have been a lot of rendering updates, again, primarily to clarify and to bring greater standardization to rendering behavior across different PDF renderers. So none of this is really radical or earth-shattering. It's primarily in terms of greater interoperability. So we removed some requirements in PDF 1.7 for the color conversion process to device color spaces to better represent how conversions to device color were being performed in the real world. We added some flexibility for rendering and for color conversion to better meet the needs of proofing and output simulation devices. So for better, more reliable soft proofing of PDF in preprint and prepress workflows. We now, in PDF 2.0, require the use of ICC standard, the ICC standard for color conversion for CIE-based source and destination color spaces. It kind of sounds intuitive, but PDF 1.7, if you looked at the spec, it didn't actually require this, but in real life, most all of us did it this way anyway. So PDF 2.0 clarifies this. And PDF 2.0 adds a new section to the rendering chapter on rendering for separations, which provides guidance for how you simulate separation color spaces in a process color workflow. So how you handle separation color spaces, how you use the alternate color space definition for separation color spaces, and how this interacts with other rendering elements when rendering a page. Inline images have gotten something that they've needed for over 20 years now, and that is a length specification. So PDF 2.0, you no longer have to hope that you find the end and the correct end of your inline image somewhere. There is finally a specified length of your inline image data. This is required for inline images in PDF 2.0. And were I to have a PDF time machine, I would probably go back and require it for things before PDF 2.0. But last I heard, my time machine project isn't working that well, so I can't go and do that. All we can do is from PDF 2.0 forward. We now have, this is stored in the L key, an inline image, that specifies the length of filtered inline image data. So like image X objects, this length specifies the actual length of the binary data blob that you have in the PDF. It does not specify the decoded length. You still need to decode your stream to find that out, just as you need to do with image X objects today. So there's no more inferring the end of data or hoping that you got it right. And there's a recommendation that inline images be no more than 4 kilobytes in length, 4,096 bytes. For better or worse, this is a recommendation which, as all the practitioners in this room understand, means that some people feel free to ignore that, But if I catch you ignoring it, I'm going to give you very, very sad faces and pretty please ask you to keep the inline images to their 4K recommendations for the good of all of us. Output intents. So output intents have been extended in PDF 2.0. They've gained some capabilities, some of which were in some of the earlier PDF subset standards, such as PDFX, some of which are new to PDF 2.0. Most importantly is that output intents are no longer only document-wide. You can now specify an output intent for each and every page of a PDF document. One of the key things this enables is much more reliable merging of multiple PDFs when these PDFs use different output intents. So there's no longer the need to convert to one output intent when merging documents together. Output intent ICC profiles, while they still can be embedded in a document, are no longer required to be embedded for use in an output intent. An output intent may now reference an external ICC profile either by URL or by file name on the file system that the PDF's being processed with. The URL reference is very interesting because this mechanism for referencing output intent is not bound by the restrictions that embedded ICC profiles are bound by. And this allows ICC profiles that represent color spaces above and beyond CMYK, grayscale, and RGB-based color spaces to be represented. So N-channel color spaces where you have more than your standard set of colorants, these ICC profiles can now be used in output intents through a URL reference. For separation colors, for spot colors, there's been added spectral data characterization to allow giving the characteristics of separation colors that are used in a referenced, an output intent that has a profile reference to better characterize how these separation colors are rendered and what their characteristics are like. And then finally, output intents add what are known as mixing hints through a mixing hints dictionary that gives information about how different colorants in a device N color space interact amongst each other. So when they are put down on an output substrate or media, what the interactions between these different inks or simulated inks are. So a note on output intent usage. So output intents are intended for use in PDF files that conform to a stricter subset of PDF than just plain PDF. So typically for PDFA or for PDFX or PDFVT or for PDFE files. This was the original intent, and in theory, there's no impact on any changes to output intent until these standards have PDF 2.0 versions that come out. But in practice, we see a lot of just plain PDF files that are not conformant to any of the PDF subset standards that nonetheless take advantage of output intents for characterization of various desired output characteristics. This is not prohibited by PDF. It's not prohibited by PDF 2.0. Technically, whether these are used or not by your PDF 2.0 processor it's up to the processor how these are used, if these are used, which are used. So be aware that when you have output intents in a PDF 2.0 file, that the results may be unpredictable in a general case. If you have a closed workflow or a workflow where you know the consumer of your PDF 2.0 file will be using output intents and can handle these and know which they can handle, then this is a good use case for using output intents in PDF 2.0. But do be aware that if you use output intents and you don't know the characteristics of your receiver and what they are and aren't capable of using, that results might not be 100% what you expect. Now, there's my little warning on output intents. Halftoning changes. There have been some significant refinements and some functional extensions to halftoning in PDF 2.0, including a section on advice and best practices for how to use halftones and how to process these and how to get the same results in processing PDF 2.0 files and in writing PDF 2.0 files for those instances where you want to match PDF 1.7 behavior. There's a new graphic state parameter, a dictionary parameter, halftone origin, which allows you to specify a non-zero-zero origin point for your halftone functions, which can be used to reduce the misalignment that you can see sometimes in halftones across multiple pieces of rendered PDF page content when these are slightly out of alignment. Dot shapes can now be specified with names that are not defined in PDF. So just like output intents, this very much is predicated on your PDF recipient understanding the name, the value, and the meaning of your dot shape. If you specify a non-standard dot shape in a PDF 2.0 file. So this is device specific, it's receiver specific, and well, you can specify an array of dot shapes. Your receiver will use the first name that it actually understands and knows what to do with. So if you have a fallback, for example, of say a normal dot shape, then if you use a custom or a dot shape that's not defined in PDF 2.0, then that will get picked up if your recipient of your processor knows what that is. Otherwise, you'll default to that normal dot shape. And there have been some refinements to how halftoning is processed in the context of transparency compositing. And specifically, there was a requirement in PDF 1.7 that when halftones and transparency interacted for compositing, there was a requirement to use the default halftoning algorithm for that operation, which we found over the past decade is just not nearly flexible enough for applications in the PDF rendering space. So in PDF 2.0, that requirement has been removed. And non-default halftoning algorithms may now be used in transparency rendering. So deprecations, those things that I didn't tell you about because they're things that we'd really rather people didn't know about that ever existed in PDF, but, well, due to the rules of standards, we can't just wipe them off the map. We can only say that these are deprecated. So before I go into these, I want to talk a minute about what deprecation is. If you read the PDF 2.0 standard, deprecation is defined as when a feature, when it is deprecated, it means that a writer of PDF 2.0 files, you shall not write it. Don't do it. Don't do it. But if you are a consumer of PDF 2.0 files, then you should ignore it. But should isn't you must. It's, well, some things will, some things won't. This is kind of the best we can do for removing features in PDF. So we have deprecated a few important print-related features. Well, these are separation dictionaries. That is, in PDF, you could define kind of pre-separated PDF pages. You could define an array of pages, each of which represented a pre-separated plate, if you will, for print processing. The ability to do this has been deprecated in PDF 2.0. It's now on the PDF processor to generate separations if so, as it so sees fit. Trapping and trap networks, trap annotations have been deprecated from PDF 2.0. Again, trapping should either be baked into your PDF file through normal graphic operations, or preferably performed by your PDF processor at rendering time in the manner that makes the most sense for your PDF processor. OPI, Open Prepress Interface Image References, have been deprecated. These were in fairly widespread, quote unquote, use 15 or 20 years ago, not so much anymore. Nowadays, we tend to just kind of include images in PDFs, and when we want alternates, we have more generic and general case mechanisms for file inclusion. So OPI has been deprecated. And viewer preferences, a few of these that are print-related have been deprecated. The view area, the view clip, the print area and print clip viewer preferences. You really should use the relevant page box for these values instead. I mean, we do define bleed box, trim box, other boxes in PDF for these specific purposes. So we made the decision to deprecate these in PDF 2.0. Some degenerate cases of functionality have been deprecated as well. So standard 14 fonts are now required to have font descriptors. There's no more getting away with just very bare references to standard 14 fonts. Now, of course, this doesn't mean that they have to be embedded. It's just that they are now required to have font descriptors included. Annotations, for more reliable rendering, finally are required to have normal appearance streams, at the very least written into the PDF file itself. So this leads to more reliable rendering behavior in support of viewers that may be able to render an appearance stream for an annotation, but are not necessarily able to synthesize them on their own from an annotation appearance dictionary. Just a quick correction, this slide, the use of that should be a lowercase fpath operator. I blame autocorrect. I also blame the PDF file format for very diligently and very accurately representing this author's wrong intention here. The lowercase f path has been deprecated. You should use the equivalent uppercase, that f is correct, path operator instead. And finally, halftone transfer functions are deprecated in graphic state dictionaries. For those who are using halftone transfer functions, you should specify these in your halftone dictionary instead of your graphic state. So just to wrap it up, and for those who have been napping, you can gently bring yourself back now. So PDF 2.0 contains some important additions and updates that bring greater reliability, greater understanding, and a better common ground for rendering, for color processing, color conversion, and viewing and printing. These PDF 2.0 changes, they affect producers and consumers both. But as I said at the beginning, most of these changes are backwards compatible or are in cases that only advanced workflows tend to take advantage of in PDF. So these will not tend to significantly impact PDF viewers or PDF processors that are not yet 2.0 aware, do not yet fully handle PDF 2.0. So with that, I want to say thank you. And if anyone has any questions, I'll be happy to take questions at this time. Thank you.